Okay, guys. Hello. This is section 15.3. Okay. Math 1033. Okay, and we're going to talk here in this section about least common denominator. So let me give you the definition. The least common denominator, the shortcut is Lcd of 2 or more rational expressions is defined as the least common multiple of the denominators. So what we're doing here, we're finding the multiple of given the denominators. Technically, we're looking for a number which can divide our denominators. Since there's many of them, so we're going to pick the least one. Okay, so let me just give you the example. Find least common denominator of 1 over 20 and 1 over 8. By the way, why we're learning that? Because soon what you guys going to do in next section, we'll be adding rational expressions. And to be able to do that, we need to get them having the same common denominator. And we want to pick only one, which means we want to pick the least common denominator. Okay, so least common denominator. Okay, so what you're going to do first? You're going to check your denominators, right? So you have 20, right? So what you can do with 20, you can rewrite, so the best way actually, so find least common denominator of 20 and 8, which is 40, okay? But how we know that? So technically what you can do the prime factorization. So we can see that. You take 20, you divide by 2, you end up with 10. 10 divided by 2 will give you 5. So you can rewrite 20 as 2 times 2 times 5, which is the same as 2 to a second power times 5. So that's 20. Now you will do the same thing with 8. Do the prime factorization. So rewrite 8 using prime factors. So 8 divided by 2 will give you 4. 4 divided by 2 will give you 2. So you can rewrite 8 as 2 times 2 times 2, which is 2 to the third power. Okay, so that's 8. 2 to the third power. So least common denominator of 20 and 8. Okay, so what you're going to do, you're going to take each factor, and then if they are repeating, you're going to select the one which has the highest exponent. So from 20, like we see, we have 2 to a second power, and 8 also is using factor of 2. However, it's to the third power. So what you're going to do, if the factor repeats, you're going to select the one which is to the highest exponent. So we're going to have 2 to the third power. And again, then what you're going to do with 5, you cannot just leave it. So the one which does not repeat, you're just going to copy down. You're going to multiply times 5. So 2 to the third power, it's 8 times 5, which is 40. So least common denominator of 28 and 8, it's 40. Okay, 40 definitely can divide 20. 40 definitely can divide 8. Also, one note about least common denominator, that denominator should not be smaller than one of the biggest number which you have in the denominator. So like you see, the higher number is 20. So your least common denominator has to be 20 or bigger. Okay, so keep that in mind. So now, everything what I just told you guys, I'm just going to write for you in steps. So steps of finding the least common denominator. Okay, of two or more rational expressions. Okay, so what you're going to do first, and I recommend it to write down those steps. So especially at the beginning when you guys learning, okay, that those steps will help you. First step is factor all denominators completely. That's step one. Step two, the least common denominator is the product of unique. That means you cannot skip any factor. Unique prime factors. Prime factors, that means you factor completely. Okay, there's nothing else what you can do with that. From the denominators in which each factor is raised to the highest power. To which appears in any denominator. Okay, so couple things. Okay, let me just factor all denominators completely. Super important. That's the first one. The least common denominator is the product of unique prime factors. Okay, so if the factors are repeating, which one you're going to select? You're going to select the factor which is raised to the highest power, which means the highest exponent. With the practice, you guys will see that that's going to make sense. So let me show you the examples. Example 1. Find the least common denominator for each set of expressions. So in this section, we're just learning how to find that least common denominator. In next sections, we're going to add and subtract rational expressions using what we learned here. So let's do first one using just regular fractions. you have 3 over 8, 7 over 10, and 1 over 15. And you need to find least common denominator. Okay? So first, factor all denominators completely. So we take in the first one, which is 8. 8, we did that before. 8, it's the same as 2 to the third power. So let me just use the previous example. 10, 10, you have to factor completely. That means rewrite using prime numbers. Prime numbers, that's the one which can be divided by themselves and by 1 only. So 2, 3, 5, 7, 11, 13, and so on. So 10 is the same as 2 times 5. Okay? Which again, if you don't have a power, you can just always put 2 to the first power and 5 to the first power. 15, rewrite using prime factors, so that will be the same as 3 times 5, which we always can say that this is the same as 3 to the first power times 5 to the first power. So, second, what will be the least common? What will be the least common denominator? Okay, so how you find the least common denominator? Select factors which repeat and pick the one with the highest exponent. So in our case, factor which repeats, it's 2 to the third power and 2 to the first power. So the one which repeats, you select the one which is to the highest exponent. Okay, so LCD will be 2 to the third power. Again, the least common denominator is the product of unique factors raised to the highest exponent. Okay, so we have it. Next, also what repeats? Cannot select different one. Okay, we have 5 to the first power and 5 to the first power. Since both of them are raised to the same exponents, so we're just going to multiply that by 5 to the first power. Okay, and don't forget that LCD by definition is the product of unique factors. So the only factor which we didn't use, it's 3 to the first power. So you still have to use it. So we need to also multiply that by the one which is unique, times 3 to the first power. So you including all the factors. Simplify that, and that will give you 8 times 15, which is 120. So 120 is the least common denominator of 8, 10, and 15. Or you can think about least common divisor of 8, 10, 15. It definitely works. 120 divide 8, 120 divide 10, 120 divide 15. And when you divide it, you get an integer. So let me finish the note which I wrote for you. Select factor which repeats and pick the one with the highest exponents. And multiply by the remaining factors. So those unique factors, remaining factors, which you don't repeat, you just keep them, okay? Okay, so let's do more. The next example, So we're going to slowly build into something more advanced. You have to find LCD, okay, of two expressions, 1 over 5a to the third power, b to a second power, and the second rational expression is 1 over 10a to the 4th power b. Okay, so we need to find least common denominator. Okay, so least common denominator. So we have two denominators here. So factor each denominator completely. So let's take the first one, 5a to the third power b squared. This is already factor. 5, it's a prime number, a to the third power, b second power, so there's nothing what we need to do. Now, next, factor the second denominator, which is 10a to the power of 4b. So technically what you can do, you can factor 10. 10 is the same as 2 times 5. So rewrite 10 as 2 times 5. So we're having 2 times 5 times a to the power of 4 and b. So now LCD, it's going to be, okay, let's see the factors which repeating first. So we have 5 and we have 5. That repeats. They both are raised to the power of 1. So we're putting that 5 to the power of 1. We're good here. Now, what else is repeating? We have a and we have a. We have a to the third power, a to the fourth power. So you're going to select the one which has the higher exponent. So we're going to multiply that by a to the 4th power. Okay. Now, what else we have? We have 5 square and 5. B square and b. b, it's raised to the power of 1. This b, it's raised to the second power, so we select the higher exponent. Okay? And now be careful, because it's easy to lose. Make sure that you have a product of factors raised to the higher exponent, unique factors. So we still have 2, okay, which we cannot forget, and multiply that by 2. So LCD will be 5 times 2, which is 10, a to the power of 4, b squared. So this is the LCD, least common denominator. Okay, let's do more. Example 2. In example 2, we're going to find least common denominator for each pair of rational expressions. So we're adding more. You guys going to see more advanced examples. A, we have rational expression x over x squared minus 16 and 2 over 3x plus 12. So we need to find least common denominator of x squared minus 16 and 3x plus 12. So how are you going to do it? Again, first, factor, remember about this, factor each denominator completely. So let's take that x squared minus 16. How you can factor that? Hopefully by now you guys recognize that you can rewrite this as x squared minus 4 to a second power. And remember the formula a squared minus b squared, which is difference of two squares. To factor something like that, this is the same as a minus b times a plus b. A and b, that expressions which you see in front of exponents, which will be x and 4. So to factor that, you're going to rewrite that as x minus 4 times x plus 4. Okay, so we factor x squared minus 16. Now we're going to factor the second denominator, which is 3x plus 12. Here, you can only factor GCF, the greatest common factor, which is 3. And that will be 3 times x plus 4. Okay. So now we have to find the LCD of x squared minus 16. So maybe you want to rewrite that. So find that LCD of x squared minus 16, which is the same as x minus 4 times x plus 4. Okay, so I'm rewriting that using our factors. And 3x plus 12, which we just factor, and this is the same as 3 times x plus 4. Okay, so what's going to be LCD? First, I recommended to work with the factors which repeats. So the factor which repeats is x plus 4 and x plus 4. They both are raised to the power of 1. So we're going to copy that once, x plus 4. Okay, and you multiply that by the remaining factors, which don't repeat. So what is not repeating? We have that x minus 4. So multiply that by x minus 4. And from the second denominator, the remaining unique factor, it's 3. So you need to multiply that by 3. So LCD will be 3 times x plus 4 times x minus 4. Okay, so that's our solution. Okay, let's do more. Example B. So find least common denominator of those two rational expressions. We have 6 over t squared plus 5t minus 14. And the second rational expression is 8 over t squared minus 3t plus 2. So I just want to mention that to find the LCD, you guys follow the steps which I gave you here. What happened with our examples, they just become more advanced, which means we need to do more factoring. Okay, so step number 1, factor all denominators completely. So the step 1 will start taking a little more time because the denominators which you see here are more advanced. Okay, so first, factor each denominator. So let's work with the first one, our quadratic denominator, t squared plus 5t minus 14. We're going to factor this using AC method. A is equal 1, B is equal 5, C is equal negative 14. This is easy case since A is equal 1. Okay, so we're going to factor this. So first multiply A times C, we're getting 1 times negative 14. You're getting negative 14. Next, we're going to find two integers, which products will give you AC, which is negative 14. And the same two integers by addition gives you coefficient B, which is 5. So what's going to work here? 7 and negative 2. So that t squared plus 5t minus 14, you want to rewrite using factors, which will be t plus 7 plus first integer times t plus second integer, which is plus negative 2. Okay. Next, what I'm going to do, I'm going to factor the second denominator. Okay. So we're going to factor t squared minus 3t plus 2. Okay, so the same thing, factor with AC method. Okay, so A is equal 1, B is equal negative 3, C is equal 2. So A times C is equal 1 times 2, which is 2. Find two integers which products will give you 2. The same two integers which products will give you B. B is negative 3. So negative 2, negative 1. Negative 2, negative 1. This is easy case. A is equal 1. So you're going to rewrite t squared minus 3t plus 2 as t plus first integer times t plus second integer. Okay, so we have it. Next, second. Okay, find Lcd of our denominators. So don't forget that t squared plus 5t minus 14 is the same as t plus 7 times t minus 2. I recommended to rewrite that using your factors. And LCD of t squared minus 3t plus 2, which we just factor. And this is t minus 2 times t minus 1. Okay, so what will be LCD? Okay, so note, keep repeating factors, not keep, maybe select. Repeating factors to the highest exponent and multiply by the remaining unique factors. So this is how I find LCD. So LCD. So let's see the factors which repeats. What repeats? T minus 2 and t minus 2. Since you don't see the exponent, that means they both are raised to the power of 1. Okay, so we just copy this once to the power of 1. And that's it. The rest of the factors don't repeat, so you just copy them. And this one don't repeat, so just copy this one. So least common denominator is t minus 2. Okay, to the power of 1, which is just t minus 2, times t plus 7 times t minus 1. Okay, so that's our answer. Okay. Let me just pause the video for a second. Okay, so we continue. Next, that will be the second objective of this section. So we're still working on the same thing, but here I'm going to give you steps of writing rational expressions with the least common denominator. So this is very important because we're going to use that in the next section. So we're going to have rational expressions. We'll find the least common denominator of our rational expressions, and then we will convert each original expression to the new one, which again, they will be equal, but with a denominator, which is least common denominator. So let me write the steps and I will explain that. Okay, so first, step 1, identify the least common denominator for the expressions. Okay, so we're going to do it, follow the steps which we learned already. Step 2, multiply the numerators and denominators of each fractions I will put original fractions by the factors from the least common denominator that are missing from the original denominators. Okay, I want to just give you easy example and explain it what we're doing here. Okay, example. Okay, let's say you have 1/2 and 1/5. Okay, so we want to write rational expression. So technically, let me write this. Write each expression with the least common denominator. Okay, so this is what we're going to do because maybe it looks complicated, but I want to explain it based on that easy example. So step number 1, you have to identify least common denominator. So step 1, least common denominator of 2 and 5, we know it's 10. 10 can divide 2, 10 can divide 5. Okay, so it's 10. So step 2 explains this. You take your original fraction, the first one, 1/2, and you want to rewrite these fractions using the least common denominator. Okay, so I want to rewrite 1/2 having denominator 10. Okay, so you creating equivalent expression. Okay, so what happened here? How I can convert this fraction? So technically, I will need to multiply. Let me just move that. numerator and denominator of my original fraction by 5. Okay? Because again, maybe I didn't show work, but to find that least common denominator of 2 and 5, 2 it's a prime number, so you take that 2, which is unique factor, and 5 it's a prime number, so factors of 5 will be just a 5, and we got that 10. So again, 1/2 missing has 2 as original denominator, but the one which is missing is 5. So I multiply top and bottom of 1/2 by 5. And we create that equivalent fraction, which is 5/10. And you will do the same thing with 1/5. Okay? You want to rewrite using the least common denominator. Least common denominator is the same as 10. Okay? So 10 is the same as 2 times 5. Since we already have 5, so the missing factor from LCD is 2. So we multiply top and bottom by the missing factor. And that's how we're building equivalent fraction. 1/5 is the same as 2/10. I'm not sure if that helped, but this is what we're doing with rational expressions. Okay, we're building equivalent expressions using LCD as a factor. So let me give you example 3. Okay. For each pair of expressions, find least common denominator and then convert each expression to equivalent fraction with denominator equal to the LCD. Okay. A, you have 2 over RS squared, and then we have negative 1 over RQS. Let me just pause and see how long is that video, because I don't want to lose it later and not be able to upload it. 38 minutes. I think I can continue. Okay. So, step number 1, okay? First, find least common denominator of RS squared and RQS. So least common denominator, okay? We're checking the factors which repeats, R repeats, and R repeats to the third power, and you select the one which is raised to the higher exponent. So we select this one. And then S repeats, but you're going to select the one which is to the highest exponent. So multiply by S squared. So this is LCD, okay? We find LCD. Second, take original expression, okay? So you're taking the original first expression. And you need to rewrite this expression by having the new denominator. The new denominator will be LCD. So we want to have R to the third power times S squared, okay? So don't forget that we're converting, okay? Our new denominator is LCD. So how we can do it, okay? You're going to multiply top and bottom of your original fraction by the factor which is missing. So look what happened, okay? Let's check our denominator. We already have s squared, okay? We already have s squared, so we good here, okay? Now, my new denominator has r to the third power. Our original denominator has only r. So here, we missing r to a second power. Because we have only one r, we need r to the third power. So you're going to multiply top and bottom by the factor which we're missing. Okay, so we missing r to a second power. Okay, so then look how that works. Now we just multiply numerators together, so 2 times r to a second power. And when you multiply your original denominator by the factor which was missing, you will end up with the denominator, which is your LCD. R times r squared will give you that r to the third power. S squared, it's already there. Okay, so we have it. Okay, so 2r s squared is the same as 2r squared over r cubed s squared. They are equivalent fractions. Okay. And I'm going to do exactly the same work with the second fraction. We're going to rewrite -1, the second fraction right here, -1 over r to the third power times s as equivalent fraction where the new denominator it's LCD. Okay, so we want to have new denominator, which is LCD, r to the third power times s squared. How are you going to convert that? So the same thing, multiply top and bottom, okay, of your original fraction by the factor which is missing in your denominator. So look what happened. We have r to the third power already, so we good, okay? Now we have s, but we want to have s to a second power, so we missing s squared because we're trying to get s to the third power. So what we're going to do, we're going to multiply top and bottom by the missing factor. Okay, so now we have -1 times s squared. And that's our equivalent fraction. Okay, so -1 RQS is equivalent to -s squared over RQS squared. And why we do that? Because, like I mentioned before, we need to have common denominator to be able to add or subtract rational expressions. And right now, I'm preparing you for that. So we'll need to build those equivalent fractions with the same common denominator. And the common denominator is LCD. Okay. I have 1, 2, 3 more examples. I think I will stop and I will record the second video a little shorter. So you're going to see the second video soon. Let me just stop here. Stop recording.